Hello everyone. So in this particular video, we will see what actually the norms are. For example, if we are given a two-dimensional vector, then what is actually what we are doing when we are calculating the first norm or the second norm or the infinity norm of that particular vector. So we will look into this step by step. The first, let us look into this vector. We have taken vector v equals 3 comma 4. This is a column vector. So this particular vector is a column vector and it has two elements 3 and 4. So we will say or call these elements as v1 and v2 and this is 3 and 4. Now we represent this particular vector here in this particular coordinate frame. So what we are actually doing is we are writing this as v1 1 comma 0 plus v2 0 comma 1. So basically these two forms the basis vector, and let's say this is x and this is y, and then we are multiplying it by 3 and we are multiplying it by 4. So basically it is 3 units along the x-axis and 4 units along the y-axis. So this is how the vector looks. This is the vector v, which is this, and it is represented in a coordinate frame with x-axis and y-axis. And in order to make this vector, it consists of two elements v1 and v2, 3 comma 0 and 0 comma 4. If we want to break it into two vectors, then it is like this. 3 comma 0 and 0 comma 4 are the two vectors which combine together or add together to form the vector v. Now when we calculate the first norm of this particular vector, so what we are doing, let us look into that. The first norm of a vector v is simply the addition of its elements v1 and v2. So as we have seen in the above that the vector that we have taken is this 3 comma 4, and first norm of the vector is simply the addition of the magnitude of the individual elements of the vector. So the elements of vector v are v1 and v2, and magnitude of these vectors are mod of v1 and mod of v2, and adding them together gives us the first norm of the vector. And we can simply, if we remove the coordinate frame and look into it from the vectors perspective, given two vectors v1 and v2 which form vector v, so what we are doing is we are doing vector addition. We are adding vector v1 and then vector v2. This gives us a final vector v, which is our final vector v. Okay. Since it is a norm, it is a measure of distance, it will always be positive. Therefore, always add the magnitude of the vectors. So we see the first vector is a vector along the x-axis, which is 3 comma 0, and it is starting from 0 comma 0 to 3 comma 0, and then from 3 comma 0 we move towards the y-axis 4 units, which is the vector 0 comma 4, which is parallelly shifted by 3 units, and adding both these vectors v1 and v2 gives us this. So first norm is giving us what? First norm is giving us the addition. What we are doing when we are finding the first norm is we are doing the addition of all elements of the vector, and addition of the magnitude of all elements of the vector. In MATLAB, we have a command norm where we give the vector v and 1. So first you have to declare the vector v as 3 comma 4, and then we use this particular command for finding the first norm of the vector. So we see that our vector was 3 comma 4, and if we find a first norm, it is simply the addition of both the elements magnitude. So first element's magnitude is 3 and second is 4. On adding we get 7. So first norm of this particular vector is 7. Now we look into the second norm. What actually is second norm? So as we have represented the vector in a coordinate space, the point of origin in that particular coordinate space is 0, comma 0. So the second norm of a vector is actually finding the distance between these 2 points. And one point is actually the origin, since we are representing the vector in a coordinate frame such that the tail of this vector is at the origin. So vector v is represented such that its tail is at the origin and its head is at the point which is represented in the vector, whose coordinates are represented in the vector. So 3, comma 4. Okay. What second norm is doing is finding the distance. It is finding the distance between 2 points. So one point is 0, comma 0 origin and the other point is 3, comma 4. Okay. So we directly apply the formula of finding the distance, distance between 2 points. So if x1 and y1 and x2 and y2 are 2 points, then the distance is x2 minus x1 whole squared plus y2 minus y1 whole squared. This is the formula of the distance that is being applied here, and here one point is 0, comma 0 and the other point is 3, comma 4. So when we do this, 3 is 9 and 4 is 16, square root of 25, which is 5. So if we directly write the formula of finding the V2 norm, it is under root of the square root of the sum of the individual elements. So each individual element is squared and then it is added and then we take the square root of that particular uh, sum that we have obtained. So we get the V2 norm. So V2 norm is actually finding the distance between 2 points. Now this is true, this particular formula is true when vector tail is at origin 0, comma 0. If it is not, then simply use this particular formula, the formula for finding the distance between 2 points. So using this particular formula will give you the second norm. So that is how we find the second norm. In case of MATLAB, we directly use the command norm v and comma 2. Even if we do not give the comma 2 option and simply write norm v, then also it will give us the second norm because default in MATLAB is 2 norm. So that is what 2 norm is. Now we come to the final norm, which is the infinity norm. Infinity norm of vector v. V is, again I will write it, v1 v2 and it is 3, comma 4. Okay. And how we got this, just in case we do not forget it, it was obtained like this, 4 times 0, comma 1. So this is the coordinate frame where the vector is represented such that the tail is at the origin and the head is at the point whose coordinates are given in the vector v, 3, comma 4. Now infinity norm is what? We have two elements in this particular vector v1 and v2. The maximum magnitude or the vector with the longest uh, uh, the vector with the largest magnitude is what the infinity norm is. So here we have 3, comma 4, two elements within the vector, and the longest vector which is forming the vector v is v2. The length of v1 is 3 and the length of v2 is 4. The longest among 3 and 4 is 4. So this is what the infinity norm is. So in, if let's say in case we have a vector which has n number of elements, v1, v2, v3 and dot 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 vn. So in that case, the maximum of v1, v2 dot 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 vn, and this maximum is of the magnitude. You just keep in this in mind that maximum is of the magnitude of individual elements. Magnitude of individual elements. So this gives us what? Infinity norm. Infinity norm. So this is as simple as that. It is simply finding the maximum magnitude. The element with the maximum magnitude of the vector is the infinity norm. In MATLAB, use the command like this: norm v comma inf. Inf is the option that you have to pass in this particular command for finding the infinity norm. So these are the three norms that are actually useful for us. One is the first norm, which is simply what? Addition of all the elements. The other is the second norm, which is the square root. Uh, it is the actually distance between the origin and the point the vector is pointing to, and it is calculated by finding the square root of the summation of the square of individual elements. And the final one is the infinity norm. This is actually finding the individual element of the vector with the largest magnitude. So these three norms are of some use to us, and this is how they represent. So that's it for this lecture, and thank you.